Okay, Chapter 3, Lesson 7, Piecewise Defined Functions. A piecewise defined function is a function made up of two or more expressions. Remember, in expressions, we do not have equal signs, and those are called pieces. We're going to graph both pieces on the same graph. So instead of doing like an entire line on the graph, we're only going to graph a piece of it. So we're going to cut off part of it, and instead of drawing like this whole part, we're only going to do like maybe the middle piece or maybe the end piece or some part of it. So how we're going to do that is we're going to use tables, XY tables. So what we're going to do for this, for these examples is make a table for each part. We're going to graph just the sections that it's listed, and then we're going to state the domain and the range. So for number 6, we have two equations. So we're going to make two tables and XY tables. For the first one, we're going to use the equation negative 2x plus 3. And the second one, we're going to use the equation 1/2 x minus 1. Now, for this left table here, we're going to do x's that are greater and equal to 0. So I'm just going to use 0, 1, and 2. For this table, we're going to use x's that are less than or equal to 0. So 0, -1, and -2. Now, I know for this top table that we're only using, it says only greater than 0, but we still have to use 0. And then what we're going to do, kind of like we did on the number line, is we're going to use an open circle. Because I want to use all the numbers that are greater than 0. So I want to use like 0.1, 0.2, 0.3. That's why I can't just start with 1 on my table. For this one then, I'm going to use a closed circle because it's greater than or less than or equal to. So now by using substitution, I'm going to put all of these numbers into my equation to figure out what the y coordinate would be. So start with -2 times 0 plus 3 gives me 3. -2 times 1 plus 3 gives me 1. And -2 times 2 plus 3 gives me -1. On the second one, I'm going to put all of these into this equation. So 1/2 times 0 minus 1 is -1. 1/2 times -1 minus 1 is -1.5. And 1/2 times -2 minus 1 is -2. So now when I go to graph these, I know that the top one is starting with an open circle at 0, 3. My next point is 1, 1. And my next point is 2, -1. And I want to keep graphing in that fashion, only that piece of the graph, or only that half of the graph. For the second equation, I have 0, -1 with a closed circle, -1, -1.5, and -2, -2. And I'm going to continue in that direction for that piece of it. And that's it. For number 3, I'm going to start my first table. All 0 and greater. So 0, 1, and 2. And that's for the equation 1/2 x minus 4. So substituting in the numbers would give me -4, -3.5, and -3. For the second table, I'm using numbers that are less than or equal to 0. So 0, -1, and -2. For the equation -1x minus 1. So this would give me -1, 0, and +1. So for this first one, this is my open circle. So at 0, -4, I have an open circle. 1, -3.5, and 2, -3. And it continues up in that direction. For the red table, I have 0, 1, -1 with a closed circle, -1, 0, and -2, +1. And it's going to continue in that direction. So going back to do the domain and range, the domain is going to be all of my x values and the range is all of my y values. So I erased the first graph, so we'll have to just go off this second graph. So the domain for all of my x values, if I'm using all of the values greater than 0 and all of the values less than or equal to 0, my domain then would be all x's. For my range, looking at my y's, notice that nothing is below this line here. There's nothing below it. So all of my y's are greater than this point right here, which is -4. And everything above. There's nothing below that line. Everything in the graph is above that. So here's some more examples. In this one, we see that our x's continue forever in this direction, and my x's continue in that direction. So the domain, again, is all x's. For the range, we notice that there is nothing above this line. Everything is below this line. So it's y's that are, and I gotta into it, it's an open circle. So y's that are less than 5. On number 9, for domain, notice the x's continue forever to the right and forever to the left, all x's. And for the range, notice there's nothing below this horizontal line. So y's are greater than or equal to, because this is filled in, I'm going to use the or equal to, and that line is -2. The function f of x equals 10x plus 100 for x is between 0 and 20, and 300 if x is greater than or equal to 20. Models the cost in dollars of a speeding ticket for a person driving x miles per hour over the speed limit. Graph the function and then interpret each piece of the function. I'm actually going to do the interpreting part first. So basically when I read this for the blue equation here, if you're going between 0 to 20 miles over the speed limit, they're going to do $10 per mile plus $100 flat fee. If you're going greater than 20 miles over the speed limit, they're going to charge you a straight $300. So when I go to graph this, for my first XY table, I'm going to use numbers in between 0 and 20. So I'm just going to use 0, 10, and 20. So 10 times 0 is 0, plus 100 is 100. 10 times 10 is 100, plus 100 is 200. And 10 times 20 is 200, plus 100 is 300. Notice that I'm going to have two open circles here on this graph. So I'm going to go like 50, 100, 150, 200, 250, 300. Okay, so the first one, 0, 100 with an open circle. 10, 200, and 20, 300. That is also going to be an open circle. Then for the second part, for the red graph, I'm using numbers that are greater than 20. So I'm going to use 20, 30, and 40. And notice, no matter what, it's straight $300. 300, 300, 300. So that's going to start here, and there, and there. It's going to continue for straight 300. That's it.